Building an app in Azure is just the first step. The real challenge? Protecting it. How do you give your application a secure identity, control exactly what it can do, manage its secrets, and handle user permissions without building everything from scratch? This isn't a course on complex theory. It's a graphical, hand-drawn blueprint designed for the non-techie and the busy developer alike. We break down the absolute essentials of Azure identity and access into 5 clear, easy-to-digest stages. You'll see how to create automated managed identities, implement least privilege with precision RBAC, lock away secrets in Key Vault, and master the power of user and admin consent. By the time we're finished, you will have a complete end-to-end security architecture. Don't leave your application exposed. Let's master Azure identity and access. Join the course today. Ever tried logging into your bank without a password? That's the chaos applications face when trying to talk to databases or services without a secure identity. In the Azure cloud, this digital passport is called a service principal. Azure Active Directory manages these to handle both authentication, proving who the app is, and authorization, deciding what it's allowed to do. While standard apps use traditional service principals, those living inside Azure can use managed identities, an automated, hands-free approach. Whether system assigned to one resource or user assigned for multiple apps, Azure handles the security handshake automatically. Your developers get to focus on code, while Azure takes care of the passwords. In the world of cloud security, having an identity is only the first step. To actually get to work, an application needs specific permissions managed through a system called Role-Based Access Control, or RBAC. Think of it like a house. Instead of giving a guest a master key that opens every door, you give them a specific key that only opens the guest room. In Azure, we do this by enabling a managed identity for our app and then assigning it a precise role, such as a reader, within the settings of the resource it needs to access. This creates a secure environment where your web app can see the files it needs, but is strictly forbidden from deleting them or changing any settings. Whether your app is in the cloud or on-premises, this process follows the principle of least privilege, ensuring every piece of software has exactly what it needs to function, and nothing more. Storing passwords or API keys directly in your application's code is like leaving your house key under the doormat. It's the first place a hacker will look. To solve this, Azure Key Vault acts as a high-security digital safe for your most sensitive data. It protects 3 main things: cryptographic keys for data encryption, secrets like database passwords, and certificates for secure web traffic. The vault separates management from access. While one person might manage the vault itself on the management plane, only authorized entities can actually see the secrets on the data plane. For standard needs, a software-protected vault is cost-effective. However, for high-value data or strict compliance, Azure offers managed hardware security modules. These are physical devices so secure that even Microsoft cannot see your keys, ensuring your digital assets stay locked away from prying eyes. Building a custom login system from scratch is a massive headache for developers. Instead, they use application registration to plug into Azure AD. This creates a global blueprint called an application object, where the developer decides who can sign in, whether it's just colleagues in their own company, users from any organization, or people with personal Microsoft accounts. Once that blueprint is set, it appears in your organization as an enterprise application. This is where the IT admin takes the wheel. From this view, admins can assign specific users to the app, enable single sign-on, so employees only have to log in once, and set conditional access rules, like requiring a company laptop or multi-factor authentication to get inside. It's the perfect bridge between a developer's creation and an admin's need for secure managed access. An application being registered in Azure Active Directory is like getting a passport, but it doesn't automatically have the right to travel through your data. For that, it needs the power of yes, consent. For everyday low-risk requests, like reading a simple profile or email address, individual users can give consent. They just click Accept, a common step in those familiar sign-in with Microsoft windows. However, sensitive permissions, like reading every profile in your entire company, require admin consent. An IT administrator must carefully review the request and sign off on it for the whole organization. Admins keep control by configuring consent policies, balancing employee access with essential data security, ensuring malicious apps can't steal the company's data. Over the course of this journey, we covered how applications are secured in the Azure cloud. We first explored how every application started with a digital passport, its application object and service principal, which defined its unique identity. Next, we learned that having an ID wasn't enough. We implemented least privilege by assigning precise permissions using a system called Role-Based Access Control (RBAC). This ensured apps could only perform their specific jobs. For storing the application's secrets, we moved everything into Azure Key Vault, a high-security digital safe, instead of leaving passwords in the code. Finally, we tackled the power of yes, consent. We decided whether individual users could approve access for basic tasks or if admins had to review and sign off on sensitive organizational-wide data requests, all while balancing employee productivity and company protection.